Hi, and welcome back to another tutorial. Today I want to give you some advanced insights on some general PMF settings that we did not talk about when I showed you how to run unconstrained PMF. In the orange panel, we talked about the downweighting here, but we have here 3 additional tabs that we did not talk about yet, and I want to explain them to you in more detail. So the second tab here is all about the error matrix. The first option here is to apply a matrix scaling factor to the data and error matrix. If one has a data set that has very small errors, you can run into problems because the ME2 solver cannot deal with errors smaller than 10 to the power of -6. This is a workaround where you kind of blow up everything so that you can run the ME2 solver and it will not influence your PMF results. However, before applying the matrix scaling factor, we strongly recommend to double check your error matrix because very often it turns out that the errors were just calculated wrongly. The next option is to apply a weight to a single variable. In this drop-down menu, you can select your variable. In this box here, you can enter the weight that you want to give that variable, and then you can apply this weight factor. The next option allows to introduce a linear term into the error matrix. This was introduced for AMS data with very high concentrations, where the error was not scaling with the square root of the intensity anymore, but rather with the intensity itself. So to set a linear error expression, one just clicks here on set and enters a value for the C3, and then the error matrix will be updated accordingly. Last but not least, we have here the C-value approach. The C-value approach is used when combining data from 2 different instruments and the errors have to be scaled. We will have a separate tutorial on this. In the next tab here, we have the convergence criteria the ME2 solver is using. If the ME2 solver is not able to reach convergence, one could think about changing the convergence criteria in here. But before doing so, we strongly recommend to double check the error matrix. Typically, we see that not the convergence criteria is the problem for not reaching convergence, but rather a poorly or wrongly estimated error matrix. If after double checking the error matrix carefully, the ME2 solver still does not reach convergence, one could first think about giving the ME2 solver a bit more time by increasing the number of steps here. Only after that, one could think of changing the actual convergence criteria. There are 2 different criteria here. First of all, the stability of Q, and then also the value of Q itself that one could change here. But just to mention it once again, please double check your error matrix before changing any values in here. So then we have here the last tab where we have some other settings. First, we have here the robust mode, which is enabled by default and set to a value of 4. PMF is typically run in the robust mode to safeguard the PMF run from drifting away due to outliers. Up next, we have the normalization during each PMF iteration, and this is disabled by default. SoFi also offers the option for mass closure. This means that the sum of all factor contributions is fitted to a certain mass, for example, PM1, PM2.5 or PM10, and this total mass can be chosen here through this drop-down menu. Last but not least, we have the option for multi-time. Multi-time means that one can combine data from different instruments with different time resolution. So one can, for example, combine ACSM data with a time resolution of 30 minutes with some offline data from filters with like a daily resolution. More on this we will have in a separate tutorial. I hope I could give you a good overview over all the general PMF settings that SoFi offers. Subscribe to our channel and stay tuned for more detailed videos. Thank you for watching today and hope to see you soon.